All right, today we are unpacking a material that, looks pretty simple on the surface. It's just a sheet of glass. But this is not just any glass. Nope. This is an absolute marvel of engineering, and it's designed to withstand some incredible forces. Honestly, it might just change the way you think about the windows around you.
So let's just jump right in with a huge question. How in the world do you build a glass wall that can survive a hurricane? Or get this, even a bomb blast? I know, it sounds like something straight out of an action movie, right? But the solution is very, very real, and the science behind it is just fascinating.
And the secret? Well, it's kind of locked away inside this crazy technical name. I mean, at first glance, that just looks like a jumbled mess of words. But every single one of those terms, tempered, heat-strengthened, SentryGlas, low, is a crucial piece of the puzzle. So let's decode this thing, one piece at a time.
Okay, part one. First things first, we need to break down the basic structure. The most important thing to do right now is to just forget the idea of a single pane of glass. That's not what we're talking about. This is a super engineered assembly.
The easiest way to picture this is to think of it like a sandwich. Seriously, the core idea here is laminated glass. You've got two outer layers of glass, that's our bread, and then a super strong polymer filling that's bonded right in between them. But here's where it gets really, really clever. The two glass layers, the bread and our sandwich, they aren't the same. It's an asymmetrical design, and there is a very, very specific reason for that. So yeah, why on earth would you use two different types of glass?
Well, it all comes down to a trade-off between strength and how it fails. On one side, you have tempered glass. It's incredibly strong. We're talking 4 to 5 times stronger than normal glass. And when it breaks, it shatters into thousands of little pebble-like pieces, which is much safer. Then, on the other side, you have heat-strengthened glass. It's not as strong, but it has a really low risk of just breaking on its own. And when it does fail, it cracks into big pieces that tend to stay locked together. So this asymmetrical strategy, it really gives you the best of both worlds. The outer layer is tempered, right? That's for maximum impact resistance, and it's designed to shatter into those harmless granules. But the inner layer is heat-strengthened for reliability. It's way less likely to fail on its own, and it provides a stable backbone. So you get immediate safety and long-term durability. Genius. So we've covered the bread, but honestly, the real magic of this glass sandwich is the filling. The secret to its absolutely incredible performance, it's all about the material holding it together. And that filling is called SentryGlas, or SGP for short. Now, this isn't your standard plastic interlayer. No way. It's a special type of polymer called an ionoplast. And it was developed for one of the most demanding jobs you can imagine, protecting buildings from hurricanes. So just how strong is this stuff? Get this, SentryGlas is up to 100 times stiffer than the conventional plastic interlayers you'd find in most safety glass. 100 times. And if that wasn't enough, it also has 5 times the tear strength. What that means is it's incredibly difficult to rip or puncture, which is, pretty critical when you're talking about flying debris or a direct hit. And to put that stiffness in perspective, SentryGlas clocks in around 300 megapascals. That's just a huge leap over standard materials. But here's the key takeaway. That incredible stiffness forces the two separate panes of glass to act like one single thick, solid unit, and that dramatically increases its overall strength. This quote really sums up its most important job perfectly. Even after both layers of glass have completely shattered, that SentryGlas inner layer is so ridiculously strong that it holds all the broken bits together. It keeps the panel locked in its frame, and it maintains a secure barrier. Okay, we've covered the glass, we've covered the interlayer, but there's one last piece to this puzzle. It's an invisible coating that plays a huge part in how the whole building performs. And that final component is right there in the name, LoE ES73. This is what's called a low-emissivity coating. It's a microscopically thin, totally transparent layer on the glass. You can't see it at all, but it acts like a smart filter, controlling exactly what kind of energy can pass through. Let's just look at the numbers for a second. The key metric here is something called the solar heat gain coefficient, or SHGC. It's a measure of how much of the sun's heat gets through, and this glass has an SHGC of about 0.73, which is extremely high. It also lets in a ton of visible light, 77%, while giving you a decent level of insulation. So, what does that super high SHGC actually mean in the real world? It means this glass is specifically designed to let roughly 73% of the sun's heating energy pour directly into the building. It is literally built to welcome the sun's heat inside. And that tells us exactly what this coating is for. It turns the window into a passive heat collector. This is not the kind of glass you want in a warm climate like Florida. Oh no, this is engineered for cold northern regions. Think the northern US, Canada. In places with long, cold winters, capturing all that free solar heat can make a massive difference in a building's heating bills.
So there we have it. We've decoded the name, we've got our two types of glass, the super strong interlayer and the invisible climate shield. Now let's put it all together and see how these pieces work as a complete system.
So imagine a major impact. The system kicks into gear in 3 stages. First, that outer tempered layer shatters safely into all those little granules. Second, the SentryGlas inner layer absorbs the energy, kind of like a trampoline, while holding all the broken pieces securely in the frame. And finally, the inner heat-strengthened layer, even if it cracks, it stays in large pieces, providing crucial leftover strength to the whole window. So where do you actually need this level of performance? Well, it's essential for buildings in hurricane zones, for high-security facilities that need blast or forced entry resistance, and even in minimalist architecture, where the glass itself is a structural element, like in glass fins or canopies. And, as a bonus, it also happens to be a fantastic acoustic insulator. Now, as you can probably guess, this level of engineering, it doesn't come cheap. A quote from our source material really confirms this is a premium, high-cost solution. It's something that's justified only in those critical situations where the stakes are incredibly high. And that really brings us to a final thought. We've just taken a deep dive into a material that was designed for extreme situations. But as our world faces more extreme weather and new security threats, it really makes you wonder, will super materials like this one day shift from being specialized to becoming our new normal?